Hey again guys, and welcome back. You guys have seen the title, so you know where this is from, but at the moment, while I'm recording, I don't know what the title's going to be. I think, however, this is a package from Alice1101983, and this here will take the record as the longest a package has ever taken to get to my house. Now if you'll notice, January 29th when I ordered this, that was like coronavirus time, and May 25th when I got this is when North America was in coronavirus time, or is in coronavirus time. So it's not really Alice's fault, the items in here. This is what I ordered from Alice: 870, 150, 180, 175, 177. We'll see what's actually inside here because the description shows only 4 items. So we'll see. Now, Alice actually resent the package, so this could be actually the second one. So let's take a look what we have here. Yep, this is a package from Alice. So what we've got here is a relay. What we have here is an MP3 player. What we have here, some power supply boards, 5 of them. What we have here is a kit. Is that all that's in the bag? That's all that's in the bag. Let's take a closer look at each one of these items. First one up is this 12-volt relay. So relays are kind of expensive to buy individually. This one was $1.80, and I thought that was pretty good. What makes a 12-volt relay a 12-volt relay is the coil here. This coil inside is an electromagnet actually, which pulls in a contact to flip a switch. So basically over here, if you can see those 1, 2, 3 contacts there, that's the switch. So there'll be a common terminal, which is probably, it's probably the one in the middle, the little blade there. It's already connected to one of the other connections there. There's 3 connections for the switch, 1, 2, and 3. And when you power up the coil through these 2 pins here, and the diagram is on the top, then it'll flip from these contacts to those contacts. So we have a normally closed and a normally open switch in here, and the other 2 contacts are for the actual coil. We have a little LED in there, which I assume will indicate that it is working. And this 80 amp is the rating on the switch side, not on the coil side. This thing won't draw anywhere near 80 amps. So I think we should plug it up and see if we can make it work. So I have 12 volts on some crocodile clips here, and we're going to go, the coil here is terminals 85 and 86, standard automotive nomenclature. So what I'm going to do is I'm going to connect 1 to 85, and we're going to flip this around like so, and you guys keep an eye on this blade here. Hopefully you guys can see that. Okay, I'm just going to go touch it. See it flipping over? Interesting that LED only lights once I remove the connection. So this is actually an LED being used as a freewheeling diode, it seems. So allowing the pent-up electrical energy that collapses when the magnetic field collapses to come back around to the coil on the other side. Very interesting. Maybe you can see the little contacts there a little bit better this way. So yeah, simple. Very nice devices to switch heavy loads. You can actually use this to switch AC current if you'd like. I don't know if I'd trust a Chinesium one to do that, but generally speaking, the coil and the switch are isolated. Not perfectly isolated, and in fact this one here sort of looks like it's not very good isolation, but it is in theory possible to switch mains voltage with these things. Generally speaking, in a relay, the coil and the switch are electrically separate. So that's pretty cool. Let's go check out the next device. Next one up is this kit, and I have to say, I actually went and looked up what this kit is, and it seems really interesting because this here is supposed to be a FM microphone kit. So you see I have the little mic capsule there. Oh, well, that's strange. The mic capsule doesn't have any legs on it. It's just a bare capsule. Uh-oh, might have to solder some legs. We got a couple inductors, we got a couple transistors. Two transistors, 3 transistors, yeah, 1, 2, 3. These inductors, bunch of caps. Should be pretty interesting to give it a shot, but I'm not sure how I'm going to solder this mic in. I don't even know what side's the positive, but I guess that's a trouble for another day. So expect this at some point. I'm going to build it and see if we can figure out the challenges, like how come there's no legs on the microphone. On to the next one. Next up we have these modules here, which were just under $2 each, but what they are is very interesting. So these are buck modules, so they take a higher voltage and shift it down to a lower voltage, but they're adjustable, but sort of. So they have these pads on the side where you can select 5 volts, 3.3, 2.5, 1.8, and 1.5. So you just have to solder across them, and that gives you the different voltages. It has an input voltage of up to 5 to 15 volts. I guess it has to be 5 or above because that's the range on this thing. And the output voltage is those, and there's a default of 1.25 volts out. So I'm going to connect this and we're going to connect it to the multimeter over here, and we're going to figure out if this thing works. We're going to give it a spin. I might do some efficiency testing in a future video. If you're interested in seeing that, let me know in the comments below. And if you're not, well, I guess let me know also. Any feedback is good feedback. I do still read all the comments. I don't get all that many, so if you want to try to overwhelm me, put down some comments. So I think these things will be pretty cool. I don't think I want to have them sort of adjustable. I think I just want to put them in a semi-permanent fashion. So let's check this, and this should give us 1.5 volts. Oh, sorry, 1.25 volts. 1.3, that's pretty close. Okay, I'm going to turn that off. It's taking a long time to bleed down because there's not much load. So I see the 1.5 here is possible to be soldered, even though, oh, 1.25, 1.5, sorry, I got confused. So yeah, this should bring it up by a quarter of a volt to 1.5. Yep, 1.5. There we go. That's nice. Now, do I need to clear the solder off that to get it to the next level? Let's see what happens. If I destroy this, I destroy it. It's not a big deal. Alright, so I have 1.8, but we are a bit high here. I'm not sure if that's because of the other shorted pad here. So let's go and solder suck this one. Let me see if this is actually separate. Yeah, it's separated now. So let's turn that back on. Yeah, so they do need to be separated, which is okay. So we got our 1.8 volts. So let's just solder suck the one we just connected. Am I still in frame? Yes, I am. There we go. Solder up the 2.5. Still separate. It takes quite a bit of solder to actually bridge across a gap. There we go. Turn this on. 2.56, pretty good. Alright, gotta solder suck this. Bridge our 3.3. I'm actually curious to see if the 5 volts will be within USB tolerance, which I think is 4.5 to 5.5. Whoops, I did that live, so this was still connected. Well, that's pretty neat. It worked. So you guys probably noticed at some point it swapped over to the correct voltage. So that works. Let's pull this off. There we go. And get some 5 volts going. And 5.07. So yeah, this works pretty well. I'm gonna make an individual video on these things about seeing their efficiencies and seeing if maybe we can stack the voltages like you saw with the other one there, because that would mean we can make a large range of voltages. We can even go up to 5, 6, 7, 8, 9, 10. Yeah, we can get like 15 volts out of this maybe. So yeah, these boards are really interesting and I can't wait to have a play with them. And the last item we have is this thing. This was under $2, $1.70 I think. And this is a standalone MP3 player. Now, this thing is extremely cool because under $2 Canadian, so that's like around more or less $1, $1.10, $1.20 American. But it reads USB and SD, SD card MP3s. It's powered by USB. It can take a battery. It has a fairly large range. I'll put it on the screen right here. And it's got the controls here, and it can either output to a headphone jack, standard tip ring sleeve, or a mono speaker output. So I figured we'd give this thing a try. I've got this micro SD card, which I thought was broken. I thought it was corrupted. Turns out it's not. Perfectly fine. I have this speaker. It's not a fantastic speaker. It's something I actually took out of a alarm clock radio thing. So it might not sound great, but we'll have to see. I do need something for the demo. It only had one wire onto it. I might have broken the other one, so I had to solder a new wire on. Kind of interested to see how this is going to work. Now the SD card here is filled with royalty-free music, so let's just see what happens when we plug it in. It plays right off the bat. Can you guys hear that? That sounds great. So it looks like you can go previous, so this should restart this song. Nope, it actually skips. The camera battery died, so I'm back. Yeah, let's see if we can increase volume. I think it's push and hold, yep. And push and hold for decrease volume. Works pretty well. And this is previous. Increase the volume again. Yeah. So previous there, next there. This looks like play, pause, and mode. That's pause. That's play. That was a bit loud. Repeat. Looks like the light flashes differently. So yeah, this thing works fantastically. I think paired with a decent speaker, this can make a really nice little wireless sort of speaker. Pretty cool. And so these 4 items, which should have been 5 but is 4, makes up today's mailbag. Check the description below this video for an affiliate link to these items, but it'll be a search term because as of the recording today, Alice1101983 cannot ship to Canada, so they added a whole bunch of shipping charges. Your mileage may vary, but just order from whoever's the cheapest. And also a special thanks to my Patreon patrons who make these kinds of video possible. So thank you very much for watching.